Welcome to Data Science Now, a podcast by Closter about the latest trends in data science with your host, Fabio Vasquez. On today's episode, we'll learn about the process and algorithms behind the recommendation systems used by Netflix and other companies. Follow us on social media at Closter Team. This is Data Science Now.
Hello everyone and welcome to a new episode of Data Science Now. I'm very happy to be with you all here. Hopefully you're all home, taking care of yourself or your family. Make sure that you don't go outside if it's not necessary. Remember that this depends on you as well. This is the 9th episode, I believe, hopefully, of Data Science Now. And this time, I'm going to be talking about something very interesting. So, because we're all home and we're all trying to just not to survive this pandemic, hopefully you're taking care of yourself and you're watching movies or shows, something like that. And so you may be wondering if you are into that kind of stuff, how does Netflix can recommend something for me? How does Netflix can recommend a movie, a show for me? And so this is not, I'm going to talk about a lot about Netflix because it's one of the best ones we have out there. But there are other platforms like YouTube, Amazon, Google. All of them use recommender systems. And so I want to get started by first defining a recommender system in simple words. I'm gonna try not to be that much that specific about the algorithms internals. I mean, I'm gonna talk about how they work and how can you implement them. But if you wanna know more about like the actual algorithm and the math behind all of this, make sure to read the newsletter, and that's gonna happen tomorrow. So these sessions, I'm live almost every Wednesday. Not all of them. Some of them I'm not there. And I don't know what's going to happen in the next few weeks because here in Mexico, things are going to get weird because of the pandemic. But hopefully I can be here with you. And the day after that, we're launching 3 things. The podcast version of this. We're launching the YouTube video. It's going to be our recording of what you are seeing right now. And finally, you're going to be seeing a newsletter that is going to happen as an article here on LinkedIn. So if you follow me here on LinkedIn, you can click on my profile and then go to articles, and you'll find tomorrow this session, and all of the other ones are there as well. And it's just a little more information, more links, resources, and just a quick recap of what I cover here. So let me go and try to define something interesting here. And the definition we have to start with is what is a recommendation. Before talking about a system that can recommend something, I'm going to talk about what's a recommendation. When you recommend something if it's something like if you're a human and you recommend something to someone else, that means that you are telling them to do something, to see something, to hear something, or to buy something. And in most cases, you know something about that object or thing. It's very unlikely that you will recommend something to do anything or to buy something that you don't know or you don't have an idea that it exists. It's going to be impossible for you to do that. And also, sometimes when you recommend something, is that because you tried it before, or you bought it before, or you have an idea that it works, or you've seen other people talking about it and you know it's a good thing. So you care about, I don't know, your friend, your family, whatever, and you recommend a thing to them. When we add the word system here, what we mean is that instead of a person recommending something to someone else, we're having a system, an algorithm, pick something from the thing I'm going to show you right now, like how it works. But it's going to pick something, but that something is coming from a database. Normally, you need to have a system that can contain all of these like objects or movies or shows, whatever, and you can pick and the system will pick one of them, and it will recommend that to a client or a person. So I think one of your questions will be here right now is like, how does that work? How does a system start to know me? And I'm going to try to make this specific to you as a person, because the recommender systems are one of the most implemented algorithms and the ones that we interact the most. Almost everything we are doing in our lives, it's coming from a recommendation. When you want to travel to a place, you enter in Booking or Expedia or Kayak, or you search online and you find recommendations both from people and from systems. I mean, when you get a recommendation to a flight, whatever, in Kayak or Expedia, it's not someone that knows you, it's a system that knows you. Or when you go to Netflix and you want to watch a new movie or a new show, sometimes if you know it beforehand, you will look for that. But most of the time, you will it's open Netflix and see what's there, and hopefully it will recommend something that you like, and then you will watch it. Also, when you're on Amazon and you're buying stuff there, so you enter with the idea of buying something, and in the end you buy much more stuff because there were good recommendations out there. By the way, if in the moment of me describing anything you have any questions, make sure to write them on LinkedIn. I'm gonna be seeing your comments there. So hello everyone that has said hi to me before. So let me go now to the specifics on how this works. Normally, when we talk about a recommender system, we're talking about, in general, about two methods. The first one, and one of the most familiar ones, is called the collaborative recommender system, or the collaborative filtering methods. Collaborative means that you're using some input from, like some direct input from the client. Let's say that you have a system, and I'm going to talk about Netflix here right now. System is like Netflix. You go there and you watch a movie, and then you can rate that between 1 and 5, I believe. And let's say you've rated 5 movies so far. And so other people will rate other movies as well. So the process of collaborative filtering is using the information from the user as a person, and the items in this case will be movies or shows, and then with a process I'm going to describe very soon, it will take out that information and recommend something else to you. So that is based on the things you're doing, based on the things you're rating. In collaborative filtering, there's also something I'm not going to talk about that much here in this session, and it's called implicit feedback. And that's going to be a topic maybe for another discussion. But with implicit feedback, you're using not something that related to what the user or client has rated, but more about like their behavior. But when we normally talk about the behavioral systems like this, we talk about something called content-based recommender systems. And the content-based recommender systems are the ones that are using not only your ratings, but a lot of features, a lot of different events you have. So the content-based, you can define interactions, and then you can define a lot of different things that can work as an input to your algorithm. Normally, when you have these big systems like Netflix, you also have something called a mix or a hybrid method, where you have a little bit of collaborative filtering and you have a little bit about content base. So let me go right now and talk to you about collaborative filtering more in detail. So in here, before talking about that, I want to mention some numbers. And for this, I want to thank one of my friends, Daniel Mora. If you're seeing this, thank you very much. He helped me recollect some information about Netflix in particular, for you to have an idea of the numbers we have here. So before talking about one of the most used methods that are collaborative filtering. I'm going to talk about something about Netflix that it will make a case for the company. So right now, Netflix has 167 million users. Right, it's a lot of people, and they're expecting, or at least I'm expecting that with everyone at home right now, more people will buy more Netflix licenses and subscriptions. Right now, in the whole database, they have more than 500,000 movies and shows. So more than 500,000 movies and shows. There's a lot of things to watch there. They can change. So if you move to a different to a different country, you will have different shows there. But in general, like their whole database consists of more than 500,000 movies and shows. They have more than 450 billion unique events per day. Again, I'm gonna say this again. They have more than 450 billion unique events per day. What is an event here? You can be asking yourself. Netflix tracks everything. How much time you spend on the main page? How many categories are you browsing? If you watch trailers, if you saw a movie, if you're seeing a movie and you stop, they're gonna track how much time is the movie stopped. If you're watching a series, they're gonna be see what's the series, at what time you're seeing that series, how many episodes you watch, and a lot of different things, like if you're using subtitles or not, if you're changing the language, if you're rating that movie or show. If for some reason you turn off the TV, that's also an event. So as you can see here, this 450 billion unique events per day it's coming from a lot of different places. And just a quick number here. Netflix has a revenue or more than $20 billion. And that was only last year. Only last year, the revenue was more than $20 million. So how is Netflix that good? I mean, how did it change the world? You can be asking. And the thing here is that it's a very incredible recommendation system. Everything in Netflix is a recommendation. Everything you see. And I'm going to be more specific about that later. But the idea here is that they discovered that if you really want to transform the user experience when you're trying to watch a movie or a series, I mean, it could be very simple. It could be a very ugly user experience where you have two columns, movies and shows, and you go there and just browse them. I mean, that can be the case, but they realize that if they recommend things and if they personalize things a lot, then everything will change. That was their hypothesis, like what will happen if everything in the platform is a recommendation, and then they did that. And as you heard in the numbers in the last section, they did pretty good. Let me tell you something here right now. The research right now says that the member or client loses interest after perhaps 60 to 90 seconds of using. And that's having reviewed at least 10 or 20 titles, perhaps 3 in details. And sometimes they do it in 2 screens. Sometimes you are browsing with your television and you're also browsing with your cell phone at the same time. Okay, so this is a very important thing to understand here right now. And this is not only for Netflix. These specific numbers are for Netflix, but this idea of a person losing interest in 60 to 90 seconds means that you have a very short period of time to show great things to them. Because it doesn't matter if you have a million movies in your platform if the user cannot discover in those 10 in those million movies what will be good for them. So this is the interesting part. You need to do it good and you need to do it fast, and it needs to be simple. So one of the things that Netflix cares about a lot is simplicity and how good are their recommendations. Let me go here right now and tell you that just for you to have an idea, if you go to a different company, let's say Amazon is making 34% of their revenue on their recommendation system. That means that if they're making $1 million, at least $300,000 are coming from recommendations. So that's a very important number. That means that it's very important to have a good recommender system, not only if you are selling something, but if you wanted to get your product out there. And I'm going to talk about different applications of recommender systems in the next minutes. But if you do something like Facebook and you want people to click on the advertisements, you want to recommend the things that are more likely to click. Google is doing that. In the fashion world, that's very important as well. If you're in the fashion and you want people to keep buying things for you, you want to recommend things that, they won't have the time to see the entire store, and even not physically and not even in the computer. So if you want people to buy you more things, you want to have a good recommender system that can tell them, hey, you will like this, and it's very likely that you will like this because people like you are liking stuff like that. This is trending, something like that, and that could be a good thing for your revenue. Let me go and tell you something about. So we were talking about the collaborative filtering part, and the collaborative filtering part is something very interesting. Are we still live? I'm getting here a weird thing. Okay, sorry. So, if you see Netflix and you read about their story, it's not a new company at all. It's been there for some years now. And one of the interesting things that it's happening with Netflix is that back in 2009, they launched a prize. It was called the Netflix prize. And so they had a recommender system back then, and the competition was whoever can increment in 10% or recommendations, like if we can see that your algorithm is better than ours by 10%, we'll give you $1 million. So a lot of people were participating there, and they were working about it. And one team won. The winner team was by something called Pragmatic Chaos, Belcore's Pragmatic Chaos, and they won that prize. And so why I'm saying this right now is because there were a lot of great advances in the world of recommender systems coming from that prize alone. So again, if I'm not saying here that prize changed everything, because there was a lot of people working on this on different companies and schools, but this prize in particular make a lot of people, like a lot of great people, research about recommender systems. And one of the cool things that Netflix did is that they mentioned that whoever won or whoever does something interesting, they should publish that in a paper. So we have a lot of great things happening in 2009, 2010, and 2011 about recommender systems. And the key element of the winner team was something called matrix factorization. And matrix factorization is the key element behind collaborative filtering. So let me go there right now and tell you a little more bit about a recommender system that is using underneath something called the collaborative filtering. So the collaborative filtering means that, again, and just to remind you that you're getting feedback from the client or the user as a rating, maybe, and you want to use the user and the ratings to create a big matrix. So what you do in matrix factor with something like collaborative filtering is that you create a new matrix that is coming from the user and the vectors that are going to be the items that can be movies or shows. The process of transforming those things into vectors, it's called an embedding. So the embedding process is very important in the world of matrix factorization. By the way, if you want to know more about what's a matrix or something like that, in the episode number 5, on the 5th episode of Data Science Now, I talked about the math for machine learning, and in there I covered some things about matrices and this kind of stuff. Okay, so matrix factorization will transform this big matrix of user item interactions into a big like vectors of users and items, and then using something called the dot product, that is a multiplication between matrices, it will create this new reconstructed matrix that will contain recommendations. And what's the idea underneath all of this? Not every person will rate every movie. That's impossible. And not every client or member is going to watch every movie. So what happened if you want to recommend something to someone that has only liked some things? Like, let's say you go to Netflix and you have, let's say, you have liked 30 series and 20 movies in all of your history in Netflix. The idea of collaborative filtering is how can we use your information and in the information of all of the other users out there and their ratings to recommend something to you. And that's the basic idea, because we're not going to be watching every movie and show. How can I, using all of the information for other clients, can find someone that is related to you in some way and then recommend what they're seeing? Because if they saw or they watch a movie, it's very likely that you will watch that too. I mean, and you can be asking, why do we need this? And as a company, you want people to spend time in your product. You want people to stay there, right? You want people to stay there on your web page a lot. If you have an e-commerce, if you're selling stuff, you want people to see almost everything you have, and you want to keep them there. You want to keep them happy. You want to keep them searching and browsing your platform. And one of the ways we discover that this can be happening is when you recommend stuff, because sometimes you don't know about what you want to see. So if we recommend something that you don't know or do you know you need, it's very likely that you will click there, and that click will take you into a whole new world of things that you didn't know before, and you will spend more time there, and it's going to be more likely that you will buy something. So one of the most famous algorithms that implements this idea of collaborative filtering is called the alternating least squared. Again, for the people hearing this in the podcast, one of the most famous algorithms that implements the collaborative filtering is called the alternating least squares. I'm going to call that ALS from the rest of the session. So ALS, it's going to do that for you. And I'm going to talk about one implementation in particular. Netflix is using underneath a language called Scala. They use different languages like Python and stuff like that, but a lot of their systems, like their core systems, they were developed in Scala. Scala is a language that I talked about in I think it was last session, where I talked about No, sorry, 2 sessions ago, number 7, I talked about the most important programming languages for data science. One of them was Scala. So, Scala is a very interesting language, and a lot of the things that are happening right now in Netflix are coming from that language. And one of the best frameworks for machine learning in Scala is called Spark, Apache Spark. By the way, Apache Spark also has an API for Python, R, and Java. So if you don't know Scala, you can also use it in those languages. But if you see the papers from Netflix, and this is something I want to talk about very quick. All of these big companies like Amazon, Walmart, Netflix, Google, Facebook, what they're discovering, they're not just taking that to themselves. They're not hiding that things. I'm not saying that they're telling us all the truth because that's their business, but at least when they do some research, they will publish that in a paper or they will create a blog about that. So Netflix has a blog that is a machine learning blog. And in that blog, and by the way, the link to that is going to be in the newsletter. So tomorrow you'll have all of these links. And in this blog, they put like a condensate thing about their articles. So their articles are pretty hard if you don't know if you don't know algebra, if you don't know like calculus, stuff like that, or you don't know programming or machine learning. It's going to be very hard for you to read the articles or like the actual papers. But they do have this blog section where they try to explain this in easier terms. So if you go there and read the papers or read the articles, you'll see that a lot of the things they use is something called Apache Spark. And Apache Spark has a very good implementation of ALS. And it's just very simple to do. And I'm going to tell you what to do if you want to implement a recommender system in Spark right now. So what you have to do if you want to have something like this, you want to have a data set that contains the users. Okay, so for the users, you want to have, again, I'm only talking about here one of the systems and one of the ways of doing this, and this is collaborative filtering. So one of the algorithms that implement that is called the ALS, and inside of ALS, what you have to do is to have something called a data set for the users and how many ratings they have. You want to have the actual movies. You want to have a data set of movies and shows, or your items. Like it can be shoes, it can be hats, whatever you want. So you want to have the users in the database and the ratings, and for each one of those items, you want to have the table for the actual items and some description on that item, and you want to have the ratings, just like a historic rating on those items that people gave. When you have all of this, you're going to load them to Spark as a data frame, and Spark has something called a data frame as well. And that data frame will contain all of the information from the users, the items, and the ratings. And when you have that, what you have to do is just very simple. You call ALS, and you say, what is the user column, what is the item column, and what is the rating column. So you want to create like a bit matrix. And in this huge matrix, you are going to see, or you're going to have all of the information from the users, the items, and also the ratings. So you're going to pass that into the system, and you're going to create a model. And this is called in Spark an estimator. And when you have an estimator in Spark, you have to fit it to your data. And in here, you want to do the training test split. I know I haven't talked about machine learning that much in these sessions. I'm going to go there in other ones. But when you do machine learning, you normally have a training set and you have a testing set. But don't worry if you don't know the specifics here. And when you have your fitted model, what you can do is predict. You can predict your ratings for all of the movies for every user. So the idea here is that if you have 100 movies, Not every user will watch 100 movies. And the idea here of this algorithm is that it will give you a predicted rating for every movie for every user. So in that case, you can say, okay, so I wanna just take the predictions for the movies for every user when that rating is over 4 stars, because that means it's much more likely that they're gonna watch that, because it is predicting that the user will give that movie a 4-star rating. So in that case, you can take that, put that into a database, and then with some data engineering stuff, you can deploy that model into production. So this is the basic idea of the world of collaborative filtering, and this is how you do it in Spark. There's a whole world that is not the same as this one here. And this other world is called the content base. So what if you don't have ratings? You can be asking, what if you don't have ratings for your items? What if none of your users are doing that? Or you're not asking your users to rate something, to create a rating for the stuff? So in that case, a very interesting approach is to do something called a content-based recommender system. And a content-based recommender system is using the behavior of the client. I'm going to talk about Netflix here again. And let me go there real fast. So in there, you're going to define things like in which day of the week they watched a movie, when they did it, like how much time are they spending watching comedy, how much time are they spending watching like Friends, or if they watch Friends, what do they watch after that, what's the age of the client, what's the genre of the movie they're seeing. So all of these events that I mentioned before can be used to create a content-based recommender system. And normally what you do when you have all of that information is that you create something called a similarity between the clients. And that can be that can be done with different algorithms and methods. But one of the most famous ways of doing that is just having a big matrix of events. When something happened, you put a 1. When nothing happened, you put a 0 there. And you can calculate the similarities between these clients with something called the cosine similarity, the Jacquard similarity. And then when you have all of the similarities, you can see, okay, so now I don't know, or I don't have the specific for when a person is recommending, when is rating something. But if the user A watch all of these cute videos about cats, let's say you are on YouTube, the system can recommend a cat video to you. Okay, so that's the case. So if you're watching comedy all the time on Netflix and you're not giving any ratings, a content-based recommender system can understand that and recommend, hey, this is a fun comedy for you, or this is something you will be interested in watching because you've been watching all of this other stuff. And when you do that, in collaborative filtering, again, you also have these big matrices, but the idea here is to do the dot product, so a matrix multiplication, but based on similarities. So as you can be hearing right now, a lot of the things happening underneath an algorithm for recommending something is just algebra. So go to the 5th session. In session number 5, when I talk about the math for machine learning, you see that podcast, or you can hear that podcast or see that video on YouTube right now. And in there, I'll give more. And in the newsletter for that session, I talked about where you can learn all of these things. So let me go now and talk to you about something about Netflix that can be very interesting. So again, I mentioned some stuff about Netflix, but I want to go there and tell you more about numbers. So if you go to the papers in Netflix, they do a lot of different things to try to predict what what movie or show you will be seeing. And let me give you an idea here on numbers. When you have so you can just put a popular like recommendation there. Let's say you don't have a recommender system, and you can just put, okay, so or what's the show or what's the movie that is the best right now. Okay, so everyone is seeing that, and you can just recommend that in a top 10 list to a client. If you do that, it's gonna happen. I mean, it's gonna work sometimes, but it is proven by Netflix that you can increase the the number of shows and movies people watch by a factor of 4. That's a lot. If you create a personalized system. That's very interesting, and they discovered that if you do these hybrid systems between collaborative filtering and content based, and you optimize those models, you can have a 200% increase on how many movies and show and how much time people are spending on your platform. So that's very interesting numbers there. Let me go to something that you may not know about Netflix. So when you have the time later today, just open Netflix, and this is what you will see. You will see a big screen, okay, with like a big thing in the top, and there you'll have like some rows, and each one of those rows, it's gonna be something. But if you really if you really see what's that row about, and you have the title for each one of those rows there, you'll see that they're not just genre basis. It's not just the genre of the film or the show. It's not just comedy, horror, drama. It's not something like that. Sometimes it's a combination between drama or like popular shows in Mexico today, and then you have like because you watch Friends, and then you have because you liked movies with this actor. So as you can see, they're not using just the basic stuff. They're testing a lot of different things. And one of the things I told you that you may not know about Netflix is that what you're seeing is also personalized. What you're seeing there, like what is the front image for a series or a movie can change, and that's super interesting. Let's say you want to, let's say you go to LinkedIn, to Netflix, and you open it, and you have a recommendation to watch Stranger Things, a very popular show in Netflix right now. So you have Stranger Things there. The photo they're gonna show, it's gonna be personalized to you. That doesn't mean that you are like the only person in the world seeing that picture. That means that you are in a group of people that are seeing that picture, because it's very likely that when you see that picture, you will click on that movie. Because they realize that when they have a photo that connects to the audience, it's very more likely that they will be clicking on that movie or show. They're also personalizing more stuff. When they show you a picture for a movie, depending on which picture they're showing, because let's say you are seeing, or you are like browsing, and you see two people kissing. Okay. So when you do that, and when you see that in a picture for a movie, you can think, okay, this may be a romantic comedy or a drama. But if you see people having fun in the picture, you're gonna think like, oh, this is gonna be a comedy. But those two things can happen in one movie. If you watch any like romantic comedy out there, you have sometimes people crying there, people will be laughing sometimes. You will have people kissing. So if you decide which picture to put there, then you can change the behavior of people, because they will be thinking, oh, this is a comedy, I want to watch it. Oh, this is I don't know, something romantic, you want to watch it. And they can also understand on the time you're seeing things what to recommend. Because if they know that you only watch romantic things in the night, that can be that you are with your girlfriend there or with your boyfriend there. And they can recommend those kind of stuff because they know that at that time you are very likely to watch all of those things. One more thing I wanted to talk about is about how something else that is very interesting about Netflix. Again, it's very likely that you will see the things in the top left part. So when you are seeing your screen and you are seeing recommendations from Netflix, it's very likely that you will focus on the most left part. So you won't scroll that much to the right, and you won't scroll that much to the bottom part. So it's very important that they have the best recommendations in the front page. And so how do they get that? They take from the algorithm I mentioned there, they're taking the best ranked movies and shows that you're most likely to watch, and then when you scroll to the right or to the bottom, it's gonna be less likely that you're there. So the recommendations are gonna start seeing weird. Like, why are they recommending me to watch this? Because this is something I will never watch. And sometimes that can also happen for the most recommended things. You can have a very strange behavior in a platform, and you may not fit any pattern that they discover, so you're not gonna get great things out of that algorithms. One other thing that's very important for recommender systems is the testing part. So testing is crucial in machine learning. Whenever you wanna deploy an algorithm for your company, you have to test it before. And so Netflix divides the testing in two parts: the offline testing and the online testing. The offline testing is when they have some hypothesis, they train a model, they test that offline. How they start like calculating some metrics around the recommendations, and when they're happy enough with that offline testing, this offline testing is performed by machines. Okay, so when that's happening, then they go to the online A/B testing, and A/B testing is crucial for this kind of algorithms. So in the A/B testing, they choose a control group. Let's say I'm going to launch this specific recommendation to 2 million people. And I'm going to launch a very similar but not the same recommendation to these other 2 million people. And those and those groups can be in the same cluster. Okay, so you can have a cluster of people, and you can choose groups inside of your cluster. And the idea of A/B testing is that if you're not entirely sure which model is gonna perform better in the outside world, then you can test that. So they spend months in online testing, in online A/B testing, and they recollect that information. So how well was recommendation number one? How bad was the first type of recommendation? And how many people click on the shows? How many people watch? And they recollect a lot of events on that recommendation engine in particular, and they compare that to the other one. So the one with the best performance is gonna be picked, and then they can roll out to all of the members of a cluster. So that's an interesting process. You have offline testing, online testing, and then you go the rollout to every member there. So I really recommend that if you're building a recommender system, that you perform those types of testing before launching any algorithm. There is a comment here. Thanks, Fabio. Excellent material. I gotta go lunch with my son. It's his birthday. Happy birthday. Yeah, this is being recorded for people asking that. This is being recorded, and it's going to be there on YouTube tomorrow, and also as a podcast. If you are doing exercise and you want to hear me talking, because why not? Then you can just hear this podcast on Spotify, iTunes, or Google Podcast. Before ending and going to your questions, there's something I will not talk about because I don't have time to do it. But there is another way of creating recommender systems, and it's with deep learning. You can create with something called a softmax model that is a type of deep neural net. And with a softmax neural net, you can create a recommender system. And there are a lot of different ways of doing this. Go online, search. I'm going to put everything here that I show, and also a slide presentation that Danielle created for us. It's going to be there tomorrow in the newsletter. So if you want to have more material to read, you will see this tomorrow in the newsletter. I do have a question here by Justo, and he asked, data science is only predictive analytics, in your opinion, or is a lot of different tools and techniques? Data science takes place and is on top of every type of analytic. You have descriptive analytics, predictive analytics, and prescriptive analytic. Data science can be part of any of those. So when we do science, when we do data science, we are sometimes taking some stuff from descriptive studies, from prescriptive studies, and from predictive studies, and we take all of that into account to create a model and an algorithm. And I may talk about that in the future, but there's a very big connection between the world of analytics and data science. It's not the same, but data science uses a lot of the things that were discovered by people in statistics in the past decades to create algorithms. So thank you very much, everyone, for being here. Hopefully this was interesting for you. Again, remember that this is being recorded and it's going to be there tomorrow on YouTube and Spotify for you to hear or watch. And tomorrow I'm going to launch the newsletter that's going to contain all of these things I talked about here, and also some links for you to keep researching, keep studying, and just keep having fun while you're not outside. Remember to stay at home. Don't go out if it's not necessary. We are in difficult times right now in the world, and it depends on you. So everyone can be safe inside and outside your family. Thank you very much for being here. Thank you very much to my team in Closter. Thank you very much to Gabriel, Eileen, and Hazel for helping me create these live streams. And hopefully I will see you next week. Thank you very much.